Good morning, students. In the last class, we studied thermodynamic equilibrium. Okay, that is for satisfying thermodynamics, what are the status required? That is mechanical equilibrium, chemical equilibrium, and thermal equilibrium. When all these three conditions are satisfied, we call that is system is undergoing thermodynamic equilibrium. Okay, also discussed reversible and irreversible process. Okay, next today I have to discuss that important concept microscopic and macroscopic approach, and what the difference between microscopic and macroscopic. That difference can be asked for 6 to 7 marks. And last we have to discuss that what are the temperature scales. Okay, first we have to discuss that what is microscopic and macroscopic approach. These are the two thermodynamics approaches. Okay, before that, micro means what? You have to understand that micro means, all of you know that small. Macro means what? Macro means, what is macro? Macro means that large. Okay, based on that, microscopic approach means here we have to study the behavior of every molecule. Micro means small, means here molecule, n number of molecules are there. Suppose consider any system. System consists of n number of molecules. You have to study every molecules. Okay, what is the velocity, momentum, kinetic energy of every molecule? Every molecule is different for velocity. First molecule is having 2 meter per second, second is 3 meter per second, like etc. Okay, this is microscopic approach. Next, macroscopic approach means what? Here this approach, the behavior of individual molecule is not considered, but studies the properties of particular mass substance. Here means in macroscopic approach you have to consider throughout one system, that is entire one molecule we have to consider molecules throughout one substance. In microscopic means what? We have to consider n number of molecules. In macroscopic one system, throughout n number of molecules you consider one molecule. Okay, we call that is macroscopic approach. Okay, this is in general microscopic and macroscopic approach. Micro means, remember that small, that is individual molecule behavior you have to study here. Macro means n number of molecules, but throughout n number of molecules we have to consider only one molecule. That one throughout molecule you have to consider. That is particular mass. Next, that is important concept. What are that is the cap for 5 to 6 marks or 6 to 8 like that. What difference between microscopic and macroscopic approach? Already I told that micro means what? Small. Okay, microscopic approach, here the values of variables used to describe the state cannot be measured easily. That means variable cannot describe the state. Here the values of the variables used to describe the state cannot be measured easily, because that means here consider in microscopic approach n number of molecules, because the molecule consists n number. Okay, that molecule having velocity is different, kinetic energy is different. Therefore, that state that measured is difficult. The values of variable values means, suppose first molecule velocity is 3 meter per second, second is 8 meter per second, third maybe 9 or 3, etc. For that pressure, momentum, etc. Sorry, not pressure, that momentum, kinetic energy, etc. It is difficult to measure that. Okay, in macroscopic approach, macroscopic you have to consider throughout only one molecule, means one substance you have to consider. For that, the values of variables used to describe the state of matter are measured easily. Means, suppose consider one substance, you know that one substance means it is easily measure the pressure, temperature, etc. Okay, therefore here we have to measure the properties easily, that variables. In microscopic approach, what? The properties like that velocity, momentum, kinetic energy needed to describe the system. Already I told that. Here the n number of molecules are there, means each molecule having different velocity, momentum, kinetic energy. It is difficult to measure that system, but okay, these are the important properties like velocity, momentum, kinetic energy, etc. that describe the system. In macroscopic approach, what? The properties like pressure, temperature, etc. needed to describe the system. Means here, if you consider one molecule, it will easily measure the pressure, temperature, etc. That describe the system. In microscopic, third point is what? Knowledge of structure of matter is essential in analyzing the behavior of the system. In macroscopic analysis is concerned with the overall behavior of the system. That's the same thing. Here we know that individual in knowledge of structure of matter is essential in analyzing the behavior of the systems. We have to know that what are the that n number of molecules are there now. You have to know each molecule structure. That we have to say that knowledge of structure of matter is essential for the behavior of the system. Here you have to consider one system, that is one molecule throughout in macroscopic. For that, analysis concerned with overall behavior of the system. Throughout overall behavior you have to study here in macroscopic. In microscopic, next is what? The properties are defined for each molecule individually. Why your properties are defined each molecule individually means because velocity is different, momentum is different for each molecule. Therefore, here you have to find individually. Okay. In macroscopic approach, the properties of system are there, average value. Whatever the properties are there, it's the average value. Next, fifth in microscopic, what? In fifth point, number of molecules is large. Therefore, it requires advanced statistical and mathematical method to explain any chain system. That means, in micro, all of you know that molecule should be more. For that case, for calculating that velocity, momentum, etc., we require statistical, mathematical. Okay. In macroscopic, what? Here, this approach requires simple mathematical formula for analyzing system. Why this simple means? You consider only one substance of that molecule. You have to easily write that what is the pressure, what is the temperature. Okay, that we call macroscopic approach. Last point, microscopic approach is also known as statistical thermodynamics. Okay, and in macroscopic approach is also known as what? Classical thermodynamics. Why statistical means? Here we have to calculate individual molecule in microscope. Therefore, it requires statistical mathematical method. In macroscopic, we have to use classical because we have to use only system of that one molecule. It is easily noted that pressure, temperature. Okay, this is in general difference between microscopic and macroscopic. Okay, approach. Next concept, that is we have to discuss that measurement of temperature. Before proceeding that measurement of temperature, what is that? You know that all of you know the temperature. What the temperature means? What? It measures hotness or coldness of the body. Okay. Generally, there are two methods are there for measuring the temperature. First one is what? That is two standard fixed point method. Last one is single standard fixed point method. What you call two standard means all of you study in the first year, that is ice point and steam point. Okay, in the elements of mechanical engineering, all of you study that. Ice point means what? The temperature at which pure melts at standard pressure. What that standard temperature of ice point, that is 0 degrees Celsius. In two scales are there, remember that. One Celsius scale and another one is Fahrenheit scale. In Celsius scale, we have to use that 0 degrees Celsius. In Fahrenheit scale, we have to use 32 degree Fahrenheit. This is in general ice point. Means ice points means just remember that whenever ice melts at standard pressure. Steam point, all of you know the steam point. What are the steam point of steam point? That is how much that water, that is 100 degrees Celsius. All of you know that. Steam point of water, that steam point means the temperature at which water boils at standard pressure. Means this is nothing but water boiling temperature, that is you know that how much the temperature, at what temperature water boils means 100 degrees Celsius on Celsius scale. And already I told that two scales are there, Celsius and Fahrenheit. In Celsius we have to adopt that 100 degrees Celsius, and in Fahrenheit we have to use how much? 212 degree Fahrenheit. Okay, this is in general in two standard fixed point, 2 points, ice point and steam point. Okay, next is last one is what? Single standard fixed point method. Here we have to use triple point of water. Why you would call triple point of water? Water acts as triple point. Why means? Because ice in solid, water in solid act as ice, in liquid that is water, and in gas it acts as a water vapor. Okay, therefore we call that it acts as a triple point. And for that temperature we have to assign the value of 273.16 Kelvin, that is 273 Kelvin. You know that for calculating that 273 Kelvin. This is in general single standard fixed point method. Okay, this is a in general measurement of temperature. Generally 2 points, 2 standard and single standard fixed point. In 2 standard, 2 points, ice point and steam point. Okay, I hope that it is clear. Today I will discuss that microscopic and macroscopic approach, and last one is what? Measurement of temperature. Okay, thank you.